All right, congratulations. You've made it to the final lesson for the third unit. And our third unit is the application of sinusoidal functions. So 3 word problems is what I have for the note today. Really there's the theory's done. You've taken care of all the theory. So what do I want you to be able to do today? So your learning goal, I use the knowledge of transformed functions and apply them to real-world applications. So I've picked 3 representative application problems that you'll see in the homework, and it'll give you a feel for what you're doing. So the first one, the height of a Ferris wheel. So a lot of things that we're dealing with, a lot of the word problems go round and round and round because it's a repetitive function or a periodic function. So a Ferris wheel, it's modeled by this equation. So it should be added in there. F of x is height. So I've forgotten a couple things here. And x, it's time, and I'm going to be measuring it in seconds. Okay? So this models your height on the Ferris wheel at any given time. So part A, determine the period of a function. So going way back to the other day, I talked about period. P is equal to 360 divided by K. So can you pull K out of this equation? Well, hopefully. K is what multiplies the x, or it's inside the function. So our period is 360 divided by 18. So now you're just using your calculator and coming up with 20. Period is measured in time. Time is in seconds. So that's part A of the first part of A. Explain the meaning of the period. So the period, let's not pose it as a question here. The period of 20 seconds is the time to complete one full rotation. All right, period is how long does it take to repeat the cycle. So if you were going around on the Ferris wheel, one full rotation would be the period, and that is the time for that rotation. So there you are. A part answered. Again, I'm going to recommend you should have this formula on your cheat sheet somewhere. All right. B part. Determine the height after 5 seconds. Well, what represents our time? So if I just slip up a little bit more, time is x. So what it's saying is let x equal 5 seconds. So this is just a straight substitution. So f of 5 would equal 15 sine bracket 18 times 5 plus 2. Excuse me. So this is just a matter of using your calculator properly. You need to do the sine of 18 times 5 first. Then you have to multiply it with 15 second. And then finally, the last step, number 3, is to add 2. So it's just being careful with the calculator. So 18 times 5 first. Take the sine of that times 15 plus 2. And we end up with 17 meters. All right. So therefore, you would be 17 meters high after 5 seconds. All right. And C part, determine the time it takes to reach 13 meters. So now we have f of x, and it's equal to 13 meters. All right. So what we want to do is we want to find x. So if we take that same equation and I set it equal to 13, what you need to do is you need to isolate or solve for the x value. All right. So we're just using our algebra skills here. I'm going to subtract 2 from both sides, and I get 11 equals 15 sine of 18x. That 18x is inside the sine function, so we can't touch it till the very end. So we end up with 11 over 15. So again, inverse operations here. So 11 over 15, you convert it to a decimal. Too much work for me right now. How do we get 18x? How do we get rid of it? Well, we're going to have to do sine inverse of both sides. So sine inverse of 11 over 15 equals 18x. And the last step, divide by 18. Okay, so x would equal sine inverse 11 over 15, and that would be divided by 18 seconds. All right. Now, let's keep in mind that a sine function, and think of it this way. If this is 13 meters right here, my green line, okay? So that's 13 meters. The Ferris wheel is going up and down like that. You're going to be at 13 here, at here, 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 here. So this is an expression to find all times that fall into that category. All right? So you can actually calculate a value here. So for argument's sake, we can actually go ahead and calculate this with the calculator. All right? So 11 divided by 15 sine inverse. Okay, divide that by 18 equals 2.6 seconds. So I'll put or x equals 2.6 seconds. All right. When are you going to get back to that height? All right. When are you going to get back to the height? So going back to my diagram here. Oops, too far. Okay. To go from here to here, one full cycle, we said is 20 seconds. All right. To go from to the halfway point, all right, is going to be some value. And we can't say 10 seconds. All right. So at this point, I'm just going to let you leave it as a diagram. What I would do for this to make it simple is use this expression. All right. And this is how I would write it up. Because what happens is if it's not in the middle, that distance isn't going to be an even 10. And I just realized that when I was writing it up. So therefore, and I don't want to make it overly complicated. So therefore, you will reach 13 meters when x equals the sine inverse of 11 over 15 divided by 18 seconds. Okay? And then the first time occurs at 2.6 seconds. All right? And that's what I want to see when you're doing your answer. All right? There is multiple times where that occurs, but it's going outside the scope of really what the course wants, so I just want you to leave it at that. All right? So this is the expression, all right, for all time, okay? But this is the first time you reach it, okay? And that's how we're going to leave that particular question. So moving on to the second example, the volume of air in the lungs during normal breathing. So this is just you watching the, you're probably a little bit more excited because you're watching my video. So probably you're not doing normal breathing because, you know, it's just tough to contain the excitement. But normal breathing. So a person's lungs, you can have a volume between 2,200 and 2,800 milliliters of air. So the average breath takes 4 seconds. All right. So A part says determine an equation to model this scenario. First thing I would do is I'd do a sketch for myself to make it a little bit easier. So for A part, I'm going to make a sketch. All right. So here's my volume. Here's time, T. We know that it's going to be between 2,800. So I'll put the 2,800 right here. And 2,200. So we'll exaggerate it. So there's my 2,200, 2,800. All right. So what's the mid amount of air that you're going to have in your lungs? So it's going to be in between 2,800 and 2,200. So you go in between. That's what, 26, 26, no, 25. There's what, 2,800 minus 22, that's 600. Half of that's 3, yep, so 2,500. So there's the midpoint. All right, so the midpoint is 2,500. One cycle, so if I start at my midpoint, I take a breath in, I take a breath out, so I exhale, so I end up with a graph that looks like this, and just to finish it off, so there. So that's one breath. So that's breathe in, breathe out, then you go back to rest position. That time from there to there is going to take 4 seconds. Okay, so I'm just giving myself a sketch of this particular scenario. So knowing that, I know then I can find my K value. So period, K value, I'm looking for K, sorry. So K equals 360 divided by the period. So 360 divided by 4, that's going to be a value of 90. So I got K taken care of. So remember, I want to come up with an equation for this. A is my amplitude. So my amplitude is the distance from center line to the peak, or center line to the trough. So what's the distance there? It is 300 milliliters. So that is my amplitude. The center line is always your Q value. So Q is equal to center line. So that's why I always draw it on. My center line occurs at 2,500 milliliters. And my P value, if you pick sine, we're starting right at 0, 0. Okay, it's starting at the midline. That's what the sine graph does. So I'm going to pick a value of 0 here. So my resulting equation, I'm going to pick sine x minus p plus q. So y equals 300 sine, my k value is 90, x minus 0 plus 2,500. So I'm just putting in my values here. So that just simplifies down to 300 sine 90x plus 2,500. Okay? So there you go. There is your values of A, K, P, and Q. So now you can go ahead and you can answer all other questions from that point. All right? You have a model, and anytime we're going to do any calculations in the future, we are going to be using this equation. So where y is equal to volume and x is equal to time. So we have milliliters and we have seconds. All right. So for example, how much air would be in your lungs at 20 seconds? So B part, excuse me, let x equal 20. So for our function, y equals 300 sine of 90 times 20 plus 2,500. So again, just practicing with the calculator, you need to do that first, multiply second, add third. So as I go through this, I do 90 times 20 first. I take the sine of that times 300 plus 2,500, and it turns out to be 2,500. So that would mean that I am on my center line at 20 seconds. So I've done a breath, and I am right now, if I go back to the graph, I'm on this line. So I'm going to be, one of my points will be 20 seconds, which makes sense because this is 0, 2, 4, 6, 8. You're going to hit 20, so that does make sense. So therefore, at 20 seconds, I have 2,500 milliliters of air in my lungs. All right. I'm going to have to split this example between this and the next video. So I'll finish this example in the video, do the last example, and then we're all set. We have finished the unit on trigonometry.